Have you ever gazed at the night sky and found yourself pondering, why is our universe exactly as it is? Why does it seem so perfectly calibrated for stars, planets, and, well, for us? It's a question that has baffled thinkers for centuries, often pointing to what's called the universe's incredible fine-tuning. Okay, let's unpack this. Today, we're embarking on a deep dive into the very fabric of reality, exploring the mind-bending concept of the multiverse. We're going to look at how our universe's fundamental settings appear almost tailor-made for life, and then consider what that precision might imply about other possible realities.
And for this deep dive, we have a truly unique set of sources. It's quite interesting. On one side, we're drawing from, cutting-edge scientific papers by physicists and cosmologists that use mathematical models to probe the probabilities of our existence and explore hypothetical alternative universes. On the other side, though, we'll be guided by insights from a spiritual text that offers a completely different, multidimensional view of creation, existence, and, life across a vast cosmic tapestry.
So our mission here is really to explore these two distinct perspectives, right? Both profound in their own way, looking at reality and the possibility of a multiverse. We'll present what each source says, let you consider these grand ideas from multiple angles, without us taking sides or endorsing any particular viewpoint. So let's dive right into the scientific puzzle. Why does our universe seem so incredibly precise? When physicists talk about fine-tuning, what exactly are they referring to?
Well, at its core, fine-tuning describes this observation that the fundamental properties of our cosmos seem to be set by around 36 key numbers or constants. These aren't just arbitrary values. They dictate everything. How strong gravity is, how matter and energy interact.
Okay.
Think of things like the strength of the forces binding atoms, the amount of dark energy pulling the universe apart, even the initial sort of lumpiness of the early universe. And the striking thing is, if even a few of these values were slightly different, and we're talking incredibly tiny margins here, the universe as we know it simply wouldn't exist.
Wow.
No stars, no planets, and certainly no life.
It sounds like a cosmic balancing act then. Just how delicate is this balance we're talking about?
It's incredibly delicate. You could think of it like a Hollywood action hero escaping certain doom, A bullet whizzes by, a car explodes just a split second too late. If any one of those tiny details were different, the hero wouldn't survive. Our existence seems a bit like that action hero scenario. Or, another analogy, from the philosopher John Leslie, imagine a dozen bullets fired at you, and somehow they all miss. Your survival is still a profound surprise, something worth pondering, even if you wouldn't exist otherwise to question it, right?
That's a powerful image. So what are some of these critical prerequisites for complexity that the science points to? Where does this fine-tuning show up most vividly?
Okay, well, one of the most glaring examples is gravity. It's astonishingly weak in our universe.
Weak? That seems counterintuitive.
Well, compared to other forces, the electromagnetic force between two protons, for instance, is, get this, 10 to the power of 36 times stronger than their gravitational pull. It's huge.
Mind-bogglingly huge.
Right. And if gravity were much stronger, stars would be smaller, they'd burn out incredibly quickly. Even small solid bodies would be crushed under their own weight.
So no planets, maybe.
Or at least not planets where human-sized life could survive on the surface. The universe itself would be much smaller, maybe collapsing back on itself before complexity had time to emerge. Interestingly, some models even suggest a universe where gravity was 10 times weaker might actually be more conducive to life. Bigger stars, more time for evolution. The point is, its specific value is crucial.
Okay, so gravity's one. What else?
Another absolutely critical factor is the matter-antimatter imbalance.
Yes, I've heard about this.
So during the Big Bang, matter and antimatter were created in almost equal amounts. Almost. But there was this tiny, tiny excess of matter, roughly 1 part in 3 billion.
1 in 3 billion, that's it.
That's it. Without that tiny surplus, particles and antiparticles would have completely annihilated each other. Bang, gone. You'd be left with only radiation, like the cosmic microwave background we observe today. No atoms, no galaxies, no stars, no life, nothing. That tiny imbalance required very specific conditions in the early universe. The Sakharov conditions, as they're known.
That's a razor-thin margin for our entire existence. What else needed to be just right?
Well, the cosmic fluctuations in the early universe were also key. We measure this as Q.
Fluctuations like lumpiness?
Exactly. Tiny temperature and density variations observed at about 1 part in 100,000, so 10 to 5. These are the seeds, the starting points for all structural formation, galaxies, clusters, everything.
Okay.
Now, if the universe had been too smooth, so Q is much smaller, say less than 10 to 6, Dark energy would have just pushed everything apart before galaxies could form, or stars wouldn't have ignited within the age of the universe.
And if it was too lumpy?
If it was too rough, Q greater than maybe 10.3, then huge masses of gas would have collapsed very early into massive black holes. The whole environment would have been incredibly violent, far too chaotic for life to get started. So the acceptable range for Q may be between 10.6 and 10.4. While it's essential, scientists don't consider it quite as finely tuned as some other parameters, but it's still a crucial window.
Still seems pretty important.
Oh, absolutely. Then there's the need for non-trivial chemistry.
Meaning elements beyond hydrogen and helium.
Precisely. For life as we know it, we need heavier elements. Carbon, oxygen, iron, phosphorus. The building blocks. These are forged inside stars through nuclear fusion. And that process itself requires a very precise balance between the electromagnetic force and the strong nuclear force.
Okay.
If those forces were off, you might end up in what some physicists call a nuclear-free universe. Maybe stars and galaxies could still form, but they'd only contain hydrogen. No complex chemistry, no possibility for life like ours.
Right, no carbon-based life, anyway.
Exactly. And finally, let's not forget the cosmic expansion rate, which is heavily influenced by this mysterious thing called dark energy.
The thing that's making the universe expand faster and faster.
That's the one. Our universe's energy budget today is roughly 30% matter, both normal and dark matter, and about 70% dark energy. If dark energy had dominated much earlier in cosmic history, its repulsive force would have overwhelmed gravity, preventing galaxies from forming in the first place. So the right ratios of matter to dark energy, and even the presence of dark matter providing that initial gravitational scaffolding for large-scale structures to form, all critical pieces of the puzzle.
Wow. Okay, it really does sound like a cosmic lottery win when you list it all out like that. So this whole concept of fine-tuning leads to this profound question. Are we just incredibly, unbelievably lucky? Or is there something more going on here? And this, as you mentioned, is where the idea of a multiverse often steps in as a potential explanation.
Precisely. The scientific framework for the multiverse basically suggests that our observable universe, this bubble of space and time we can currently see, limited by the finite speed of light and the age of the cosmos, might just be one small part of a much larger reality.
Like an island in a vast ocean.
Exactly. We believe there are likely many galaxies beyond our current horizon that we just can't see yet. They exist, just like the rest of the ocean exists beyond your view from the shore. Now, some cosmological models, like one called eternal inflation, take this much further. They propose that our Big Bang wasn't the Big Bang, but just a Big Bang. One event creating a pocket universe within a larger, internally inflating space-time.
So infinite Big Bangs happening.
Potentially, yes. Imagine infinite bubbles of space-time constantly budding off, each potentially forming a universe. And critically, these pocket universes might even have different physical laws or constants. The space between these pockets expands incredibly rapidly, faster than light, making communication or travel between them impossible. Each one is its own self-contained cosmic island.
And string theory fits in here somewhere too, right?
Yeah, it does, offering a complementary idea. String theory suggests a vast landscape of possible vacuum states, maybe 10 to the power of 500, or even more, an unimaginable number. Each of these vacua could correspond to a different universe with its own set of particles, forces, and constants derived from the underlying string theory.
That is truly mind-bending. So, okay, if these other universes exist, would they play by the same rules as ours? Or could physics itself be different elsewhere? And how could we ever test such a huge idea?
That really is the crux of it, isn't it? What we call the fundamental laws of nature might actually be more like local bylaws rules that just happen to govern our specific cosmic patch, our universe. Many, perhaps most, of these other hypothetical universes in the multiverse would likely be stillborn or sterile. Their physics might just not allow for any complexity, let alone life. Maybe forces are too strong or too weak, or particles don't exist, or they collapse instantly. All sorts of failed possibilities.
So we only see a universe that works for us because, well, we're here to see it.
That's the essence of anthropic reasoning. We observe our universe to be biophilic, or life-conducive, simply because if it weren't, we wouldn't exist to observe it. It's a kind of selection effect.
Like we shouldn't be surprised the Earth is at the right distance from the sun for liquid water.
Exactly. We wouldn't be having this conversation if it wasn't. So under this view, we aren't necessarily in a typical universe within the entire multiverse ensemble, but we should find ourselves in a typical universe within the subset of universes that can support complexity and observers like us.
Okay, that makes sense. But can we actually test that? Can science verify if we're typical even within that life-allowing subset?
Well, that's what scientists are trying to do. It's not just philosophy. There are potential observational tests. Take the cosmological constant again, that dark energy component. Quantum physics predicts it should be absolutely enormous, vastly larger than what we observe. Observationally, it's incredibly tiny, but not zero. Now, if you calculate the maximum value the cosmological constant could have while still allowing galaxies to form, which seemed necessary for life, our observed value is only about 5 to 10 times smaller than that maximum threshold.
So it's small, but not ridiculously small compared to what life needs.
Right. It puts us maybe in the top 10th or 20th percentile of universes where galaxies could form. This suggests it's not some crazy overkill precision. It's actually consistent with this anthropic selection idea. We're in a universe that allows galaxies, and its dark energy value is reasonably typical among those that do.
But what if it was ridiculously smaller?
Well, if our cosmological constant turned out to be, say, thousands of times smaller than that anthropic upper bound, that would cast doubt on simple anthropic selection. It would suggest maybe there is some deeper fundamental physical reason why it has the value it does, something we don't understand yet. The cosmological constant problem remains one of the biggest fine-tuning puzzles, precisely because these anthropic arguments, while plausible, don't fully satisfy everyone, and standard physics struggles to explain its tiny value.
It's truly fascinating to contemplate how our universe might have been different, maybe radically different, and yet still potentially habitable. Our sources delve into some really imaginative what-if scenarios, don't they? Exploring how changing the fundamental laws might still allow for complex structures, maybe even life.
Yes, these thought experiments are crucial. They push the boundaries and show surprising flexibility. Instead of just tweaking one constant like gravity, physicists explore changing multiple parameters at the same time. It's like navigating a complex landscape. If you only change your latitude, you might stay in the desert. But if you change both latitude and longitude, you might find a new island, a different combination of parameters far from ours that is also compatible with complexity or life.
And one of the most striking examples is this weakless universe idea.
That's right. What if the weak nuclear force, one of the 4 fundamental forces we know, simply didn't exist?
How would that even work?
Well, scientists modeled this. They took the standard model of particle physics and essentially removed the weak force while keeping the other 3, strong, nuclear, electromagnetic, and gravity, the same.
And what happened in their simulations? Could you get stars, planets, life?
Surprisingly, the answer seemed to be yes, potentially. In this weakless universe, stars could still form and shine. They wouldn't fuse hydrogen the same way our sun does, but they could fuse protons and deuterium, a heavier hydrogen isotope, to make helium-3. These weakless stars would be colder and smaller than our sun, but they could burn for a long time, maybe 7 billion years.
Long enough for evolution.
Plausibly, yes. And crucially, elements up to iron could still be synthesized inside these stars. Even some types of supernovae, thermonuclear ones, would still occur, spreading these heavier elements out to form new stars and planets.
So you could get rocky planets with the right ingredients.
It seems so. Weakless Earths would need to orbit closer to their fainter suns to be warm enough. They might have less geological activity driven by radioactive decay, since that involves the weak force, but maybe gravitational tidal forces could provide an alternative internal heat source. And most importantly, the basic rules of organic chemistry would remain largely the same. So complex molecules, the basis for life as we know it, could still form.
That's incredible. A universe with only 3 forces could still be habitable.
It suggests that, yes. Which then flips the question around. Why does our universe have a weak force at all? Especially since, from a particle physics perspective, its observed strength seems somewhat, well, unnaturally strong compared to theoretical expectations. It adds another layer to the fine-tuning puzzle.
It really does. So the parameters don't have to be exactly our values, just maybe within certain ranges or specific combinations. Any other surprising what-if scenarios from the sources?
Definitely. Another really interesting area is exploring universes with different quark masses.
Quarks being the fundamental particles inside protons and neutrons.
Exactly. The masses of the lightest quarks, the up, down, and strange quarks have a huge impact on nuclear physics and chemistry. For life as we know it, we seem to need stable atomic nuclei that allow for chemistry similar to hydrogen, which has charge +1, carbon +6, and oxygen +8. These are key elements. Now, in our universe, the neutron is just slightly heavier than the proton by about 0.1%. This tiny difference is crucial for ensuring that protons are stable, and that elements like carbon and oxygen can exist and be long-lived. If the neutron were, say, 2% heavier than the proton, then stable carbon and oxygen just wouldn't exist. Chemistry would be drastically different.
What if it went the other way? Proton heavier than the neutron?
That could happen with just a small tweak to the quark masses. In that case, ordinary hydrogen atoms, just a proton and an electron, might decay quickly. That sounds bad for life, right?
Yeah, no water.
Well, maybe not our kind of water. But even then, stable forms of heavier hydrogen like deuterium, 1 proton, 1 neutron, or tritium, 1 proton, 2 neutrons, could still exist. You could potentially have planets with oceans of heavy water, D2O. And fundamentally, that shouldn't prevent organic chemistry and life from arising. It would be different, but possible.
Okay, still weird, but maybe viable.
And you can get even more radical. What if the strange quark was much lighter, closer in mass to the up and down quarks? If it was reduced by more than a factor of 10, you could get stable atomic nuclei formed from neutrons and other exotic particles called baryons, like the sigma- particle. Even in that bizarre scenario, calculations suggest you could still form stable versions of elements with the chemical properties of hydrogen, carbon, and oxygen.
Wow.
So these thought experiments really show that the conditions for organic chemistry might be met in universes that look profoundly different from our own, with fundamentally different nuclear physics. The parameter space for life might be wider than we think.
What an incredible glimpse into the cosmic laboratory of possibilities. Okay, let's shift gears quite dramatically now. We need to explore that completely different perspective on existence in the multiverse that you mentioned earlier, the one from the spiritual text.
Right. This text, Life in Multiverse, presents a cosmology based on divine visions received by someone named Balpuji. It describes creation on a scale that's almost impossible to grasp. The core concept is Behad, which signifies infinite, unlimited, boundless creation. God's creation in this view utterly transcends our observable universe, which is seen as just a tiny fragment.
So our entire known universe is just a speck.
Essentially, yes. Within this Behad creation, our solar system is considered one Brahmand, and that Brahmand is just one part of an infinite cosmic structure.
How does the text describe the structure of this infinite creation? Is it just more universes like ours?
Not exactly. It's described more like a hierarchical structure composed of 14 layers or dimensions, which are called Lokas.
Lokas.
Yes. These dimensions range from the Bhuloka, which is our Earth, the mortal world, all the way up through ascending spiritual realms. There's Swargaloka, which you could translate as heaven, and Brahmaloka, and eventually the highest level, Paramdam, the incorporeal world.
And what happens in these different lokas?
According to text, souls journey through these various dimensions. They experience different spiritual states, undergoing a process of purification, with the ultimate goal being union with the Supreme Divine. It's a framework for spiritual evolution across these vast layered realms.
And this involves different concepts of time as well, I gather.
Immensely different timescales.
Yeah.
The text talks about the cycle of birth and death for a single human soul on Earth, lasting approximately 198 crore years. That's 1.98 billion years.
Wow, okay.
And time itself is said to flow differently in the higher dimensions. One human year on Earth might correspond to 100,000 years in Svargaloka, for instance. It mentions a day of Brahma being equivalent to 4.32 billion Earth years, which is interestingly close to the age of the Earth in scientific terms. The text even acknowledges concepts that sound like gravitational time dilation, noting time slows near massive objects like black holes and also flows differently in higher dimensions. It also correctly states the speed of light.
That's fascinating how it blends these immense spiritual timescales with concepts that echo modern physics. And I understand it also talks about knowledge itself and where it comes from.
It does, yes. It introduces the idea of the Akashic record.
I've heard that term before.
It's described here as a kind of universal database containing all knowledge, past, present, and future. This knowledge is stored in the Akasha, or the ether element, and souls can apparently access this divine library. What's particularly striking and perhaps controversial is the text's claim about certain great scientists. It suggests figures like Albert Einstein, Nikola Tesla, and Stephen Hawking received their profound knowledge not just through ordinary study, but somehow tapped into this or received it from higher dimensions or even through their alien souls.
So it's proposing a spiritual or extraterrestrial source for major scientific breakthroughs.
That's the implication, yes. It presents an alternative model for the origin of human genius and discovery, linking it directly to these higher realms or non-terrestrial origins.
That's certainly a unique interpretation. Does the text delve into other mysteries too? Things like UFOs or ancient structures?
Oh, absolutely. It weaves many of these phenomena into its grand cosmic narrative. For example, it discusses life on Mars, claiming there was a past civilization, that religious wars occurred there 8,000 years ago, and even that a nuclear war happened on the planet. It references a specific individual, a young boy named Boriska, who claimed to have past life memories of Mars.
Okay.
It also talks about indigo children or star children, describing them as highly intelligent souls originating from other solar systems, born here on Earth with specific missions or purposes.
And UFOs. How do they fit in?
In this framework, UFOs are described as flying machines, but not necessarily just from other planets in our dimension. They could be from other dimensions entirely, or other planets, and are capable of traveling at or even beyond the speed of light because they're composed of subtle elements, not just the physical matter we know. It even cites ancient Indian manuscripts, like the Vaimanika Shastra, as containing descriptions of such advanced aerial craft from the past.
Interesting connection to ancient texts. What about things like crop circles or pyramids?
They're included too. Crop circles are presented as complex mathematical patterns, potentially messages, with some linked to a specific mystical symbol, the tree yantra. And the great pyramids around the world, not just Giza, but also those in Sudan, China, and elsewhere, are attributed either to highly intelligent extraterrestrials using advanced technology, or perhaps even built directly by deities, like the Hindu god Vishnu. It even mentions Area 51, describing it in familiar terms as a secret U.S. base involved in alien research, linking modern mythology into this broader cosmic picture.
So the spiritual view is incredibly encompassing, pulling together cosmology, spirituality, ancient mysteries, and modern phenomena. How does it view our own galaxy, the Milky Way, within this vast structure?
Our galaxy is referred to as the Mahabrahmand, or Akash Ganga. The text estimates it contains maybe 200 trillion stars and 50 trillion planets, with perhaps 500 million inhabitable zones, numbers far larger than current scientific estimates, by the way. And it's said to be controlled by a deity figure, Mahashiva. And then it introduces another concept, Kala. This seems to be a measure of creative power or dimensional level.
Kala?
Yes. Our solar system, the Brahman G1, is considered relatively low power, maybe 1 to 4 Kala, but this is just the beginning. The text claims there are infinite G1 universes existing within higher level great universes, designated G2 up to G17. And beyond that, infinite multiverses extending up to 100 Kala.
So universes within universes, dimensions within dimensions.
Exactly. A G2 universe, for example, is described as a higher dimension that itself contains infinite G1 universes like ours. It's a nested, hierarchical structure of almost unimaginable scale. And the creation and dissolution of these various layers, the Brahmins, the Mahabrahmans, these Kala levels, are described as vast, cyclical processes governed by these immense time periods mentioned earlier. It's a picture of endless cosmic cycles of creation and destruction across infinite realms.
What an incredible journey. We've gone from the precise mathematical constants of physics to this unbelievably vast, multi-dimensional spiritual cosmology. It's a huge spectrum of thought on everything there is.
It really is. And what's fascinating, I think, is that both perspectives, despite using completely different methods, one based on observation, mathematics, testable hypotheses, the other on divine visions, scripture, spiritual experience, they're both fundamentally trying to answer the same deep questions.
Where did it all come from? How big is it? What's our place in it all?
Exactly. The scientific view gives us the potential physical multiverse, arising from inflation or string theory, where different laws might emerge by chance. The spiritual view gives us this nested hierarchy of creations and dimensions, imbued with purpose, through which souls evolve, two radically different maps of reality.
This brings up a really interesting point, though. Whether you're talking about a physical multiverse or a spiritual one, does it imply that some laws might be truly universal, truly fundamental, while others are just local, like those local bylaws you mentioned?
That's a fantastic question, and it's something physicists and philosophers grapple with. Think about the snowflake analogy.
Okay.
Every snowflake is unique, right? Its intricate pattern depends entirely on its specific journey through the cloud. The temperature changes, the humidity, that's contingency. But every snowflake also has an underlying six-fold symmetry. That symmetry isn't contingent. It's a direct consequence of the fundamental properties of the water molecule itself. It's a deeper law.
Ah, I see. So some features are local accidents, others are fundamental consequences.
Precisely. And the hope, at least in science, is that a future fundamental theory, maybe a completed string theory or something else entirely, might eventually tell us which aspects of our universe are like the snowflake's overall symmetry, fundamental consequences of the theory, and which are like its specific pattern contingent variables that could take different values in other parts of the multiverse. We just don't know yet, which is which for many of the constants we've discussed.
So, wrapping our heads around all this, what does it ultimately mean for us? For our human understanding of reality, our significance, or maybe insignificance in the grand scheme?
It really connects to this long history of what you might call Copernican revolutions moments, where our view of our own place in the cosmos radically shifted.
Right. First, Copernicus bumps us from the center of the solar system.
Then Harlow Shapley shows our solar system isn't even near the center of our own galaxy. It's out in the suburbs.
Then the Kepler Space Telescope finds billions of other planetary systems just in the Milky Way. We're definitely not unique in having planets.
Then Edwin Hubble reveals there are trillions of other galaxies in the observable universe. Our Milky Way is just one among countless others.
And now, the multiverse. The idea that even our entire observable universe might be just one tiny bubble in an unimaginably vast ensemble, or one small Loka in an infinite spiritual creation.
Exactly. Each step seems to diminish our cosmic centrality. Yet, paradoxically, as our knowledge expands, as we grasp these larger scales, whether through telescopes or spiritual insight, human endeavor, human consciousness, becomes arguably more significant, doesn't it? We are the part of the universe, at least that we know of, that is asking these questions, that is capable of comprehending this scale and complexity. Our ability to wonder, to explore, to build models, to seek meaning. That seems pretty central, regardless of how big the cosmos turns out to be.
That's a really powerful way to put it. From the staggering precision apparently required for our universe to even exist, to the boundless possibilities of other realities, whether they're scientific pocket universes or these spiritual higher dimensions. This deep dive has definitely broadened my horizons, maybe even bent them a little.
It's a lot to take in. We've seen how science is actively grappling with fine-tuning, exploring multiverse models, and searching for ways to test them. And we've explored how ancient wisdom and spiritual traditions offer these incredibly grand, multi-layered visions of creation, where souls journey through countless realms, expanding our very definition of reality.
So, whether you find yourself drawn more to the quantum fluctuations of the early universe or the multi-kala dimensions of the Brahman, one thing seems absolutely clear. The quest to understand everything there is far, far more complex, more intricate, and maybe more awe-inspiring than any of us could have ever imagined. It leaves you wondering, doesn't it? What stands out most to you listening to this about these very different pictures of reality? How does contemplating them change your own perspective on our place in the cosmos?
And perhaps the final thought to leave you with is this. As human knowledge keeps expanding, pushing the frontiers of both science and perhaps spiritual understanding too, what new, even deeper, even more profound questions about the ultimate nature of existence itself are we going to uncover next? What haven't we even thought to ask yet?
Keep pondering, keep exploring, and join us next time on The Deep Dive.